Dear students, I am happy to welcome you all to the course on Statistical Methods for Psychological Research Part 2. In this lesson, we are going to learn interpretation of the outcome of a chi-square test. First, we go for the objectives. Students will be able to understand the concept of testing the model goodness of fit for regression models through numerical illustrations. Then, concept of testing the model goodness of fit for probability distribution through numerical illustrations. Further, association of attributes through numerical illustrations. So, you are able to apply chi-square test for the suitable statistical data. Let us start with the first part of the lesson, in which you will understand on testing the model goodness of fit for regression models through numerical illustrations. As of now, we have went with the theoretical part on the chi-square test. Now we can go through the numerical illustrations. So the first one, the following data speaks on advertising expenditure and sales. So you have to compute the chi-square test using regression models. Now here you can see advertising expenditure in thousands, that is the amount has been specified here. Similarly, the sales has been given, that is in thousands. So as you know that it is an regression model, you have to specify the variable type. Here y will speaks about your dependent variable, x will speaks about your independent variable, whereas here you have been given that the advertising expenditure amounts has been listed, that is 1000 rupees, 2000, similarly up to 10,000. Similarly here, if you have been invested 1000 rupees in your advertising expenditure, then you may obtain the sales up to 10.2, that is 10,200 rupees. Similarly, you have been placed the data here. Now coming to this solution, how you can work on this. So the problem is to study the sales observed and expected. Now to obtain the expected sales, that is your expected frequency, we consider H naught, that is your null hypothesis, as there is no significant difference between observed and expected sales of the product. As I mentioned earlier, you have to frame your null hypothesis properly with respect to your problem. By generalizing, you have been writing that there is no significant difference between observed and expected frequencies, but now here you are particular on the problem that you have been specifying as sales of the product. Automatically you have to move for alternative hypothesis H1, there is a significant difference between observed and expected sales of the product. Now you have to fix your level of significance alpha, which will be 5%, 0.05, and the degrees of freedom, total number of observations minus 1, that is you are having 10 minus 1, it will be 9 degrees of freedom. Then as I mentioned that capital Y will act as the dependent variable, or it can be also called as observed frequency, or as per the problem it will be the sales. Similarly, capital X will be called as the independent variable, or you can call it as an advertising expenditure in particular. Now coming to the linear regression model, here I have been chosen y equal to a plus bx, whereas y will be acting as the dependent variable, x will be acting as the independent variable, where your a and b will act as the parameters of the model. Our major aim will be to fit our linear regression model, that is y cap equal to a cap plus b cap x. It means that you have to identify a and b. In our earlier sessions, we have went with how to fit the regression model, that is a and b, using method of least squares. So through that methodology you can simplify and you can obtain your values a and b. As I mentioned, through your method of least squares you have to move for two different normal equations with respect to a, with respect to b. We can estimate the parameters as follows. For that, numerically we can do like this, that is capital X and capital Y as the given data. Now we have to calculate the product of these x, y, capital X into capital Y, that you can multiply 1 into 10.2, 10.2, similarly 2 into 15.6, 31.2, similarly you can extend 10 into 30 as 300, and you have to obtain the total for each column x, y and xy. Similarly you have to go for x cap 2, it means that x square, you have to square all your x values, 1 square 1, 2 square 4, similarly you can go for 10 square 100, you have to make the total for all these values. Now with this you can go for your normal equations. In earlier sessions we have been derived the normal equations. Now here you can use that normal equations here. So you can see that 203.9 equivalent to 10a plus 55b. As you know that you are having that earlier, that is summation yi, this is your summation yi, which is equal to n into a plus b into summation xi, that is the values you have been chosen. This is your first normal equation. Then similarly this is your summation xy, that is 1293.4, which is equivalent to summation xi into a plus summation x square into b, that is your 385 and 55. These are the two normal equations. By simplifying these two equations you can obtain your parameters a and b, whereas your a cap will be 8.9266, where b cap will be 2.0842. Then the fitted equation will be y cap equivalent to 8.9266 plus 2.0842 into x. While performing a numerical illustration, you have to calculate the table earlier I have shown as capital XY and capital X square. With that summations only you can frame your normal equations as in the above part, that is these two. When you obtain the totals of summation xy, summation y, summation x square, summation x, then you can obtain these two normal equations. Then by simplifying you can obtain your parameters, estimated parameters a cap and b cap, and finally you can fit your equation as y cap equivalent to 8.9266 plus 2.0842 capital X. Now I got my fitted equation. The next thing is to substitute all your values into that. That is, you can see the first column here. By substituting the various x values 1 to 10 in the above fitted equation, we can obtain the respective expected frequencies as follows. You can see here capital X is your values and Y is your observed frequency, as I mentioned earlier, OI. Now here you have to calculate your Y cap, that is your EI, expected frequency, through your fitted equation which you bought in a previous case, that is 8.9266 plus 2.0842 into capital X. Now by substituting this x value 1 here you can obtain, that is 8.9266 plus 2.0842 into 1. In the place of x you have to substitute 1, then you can get your first expected value, that is 11. Then you have to substitute your second observed value here 2 towards here, that is 8.9266 plus 2.0842 into 2. By substituting here you can obtain the second expected value as 13.1. In the similar fashion, if you extend for all, you can go for the last one by substituting the value 10, that is 8.9266 plus 2.0842 into 10, you can obtain your last expected frequency as 29.8, where I have been already mentioned that the total of the observed frequency, the total of expected frequency should match properly, that is exactly 203.9, 203.9. You can verify over here. Once you obtain your observed and expected frequency, the next immediate part will be your calculation of chi-square test. As you know, the formula for chi-square test is OI minus EI whole square by EI. It means that the observed frequency and expected frequencies difference, by squaring it, dividing with the same expected frequency, you can obtain your each and every chi-square value. By getting the total, you can go for your exact chi-square calculated value here. You can see here by substituting OI and EI, as you know that this column specifies your observed frequency OI, this column specifies your expected frequency EI. Now we can go for your formula here by substituting 10.2 minus 11.0 whole square divided by 11.0. You can obtain the value as 0.0597. Similarly, you can go for 15.6 minus 13.1 whole square divided by 13.1, you can obtain 0.4791. Similarly, if you extend for all, you can go for the end here, 30 minus 29.8 whole square divided by 29.8, you can obtain your last expected frequency as 0.0018. By summing up of all these total, you can obtain 2.3670, which is your chi-square calculated value. by using this formula only you have been utilized, that is the last one. This total is nothing but the summation. You are calculating each and every value with this formula, the final sum will represent this part, that is summing up of all. That is what I am representing as summation. I runs from 1 to 10, it means that you are summing up of all the 10 values of this formula, then you have been obtaining your chi-square calculated value as 2.3670. Now coming to the chi-square critical value. So for the previous sessions we have been went with every time, so you have to compare your chi-square calculated value with the critical value. So where you can obtain this critical value, you can see over here chi-square n minus 1, that is your degrees of freedom, it means that 10 minus 1, that is 9 degrees of freedom. So the chi-square critical value has to be calculated for 9 degrees of freedom with 5% level of significance which you fixed earlier in the problem. The value is 16.919. How to get this value? Let us see the table. Since the chi-square calculated value is less than the critical value, we accept the H naught. As you know the comparison, if your chi-square calculated value is less than the critical value, defaultly you will be accepting the H naught. Now we can go for the table, how you are getting that critical value. Now you can see this is the chi-square table, distribution table, which is a default table predefined version. So here you can see the word as d dot f, it means that degrees of freedom. So these are the values, column which speaks about the degrees of freedom, starts from 1, 2, 3, it will goes up to 50. You can go for the higher level also. Similarly you can see over the percentages here, here it is 0.05, it means that 5%, it is 0.1, it means that 10%, here it is 0.01, it means that 1%. You have been mentioning that level of significance will be 3 default percentages, that is 10, 5 and similarly you can go for 1%. Now as you know that now our degrees of freedom is 9, so 9 degrees of freedom at 5% level of significance, then the value is 16.92. So this is your table value which you can choose to compare your decision whether you are going to accept or reject H naught. Dear students, we come to the end of part 1 of this lesson. In this part 1, we have learnt how to fit goodness of fit for a chi-square test using regression models. I hope you understand the concepts which you covered here through a numerical illustration. We will meet in next video. Thank you.